Okay, welcome back, folks. Tonight, or today, or this morning, or again, whenever you're watching this, it is 1:14 a.m. local time. But whenever you get to watch this, we're going to talk about gerrymandering. And this is being recorded in a driving wind rainstorm. So if a tree falls on the house, that might disrupt your experience of watching this, but I promise I will continue recording as long as I am able. So this is going to be, I think, a shorter lecture than yesterday, at least I hope so, and this is actually the only slide where you have to write anything down. There's just the one. And so to start off, first of all, gerrymandering, it's a weird word. Don't worry about what it means yet. We talked about, okay, there's these 435 representatives, and they're divvied out to each state according to that population. But then what happens? And so we said Michigan gets 14, but how do we decide where the 14 come from? Do we elect them all at once? The whole state? Well, no. It turns out that the way this works is that every state with more than one member of the House of Representatives has to divide its state into different geographic regions of roughly equal population and elect one member of the House of Representatives from each of those what we call districts. So, for example, Michigan has 14 U.S. House of Representatives, and therefore it has 14 House of Representative districts, one for each member it elects to Congress. And so we call this idea the idea of a single member district. We elect one person from each district. Gerrymandering is when we actually change the way that those districts are drawn. We move the lines to benefit one political party or another. And you can imagine that, okay, if you have to divide the state's population into 14 equal blocks, some of those blocks are going to be much larger, right? So there's parts of the state that are not very densely populated, like the Upper Peninsula. There's other parts of the state, like the Detroit area, that are very densely populated. And so these blocks are not going to be equal size geographically, but they're going to be equal roughly in population. And there's different ways you can draw it. You can sort different parts of the state and put them together in different ways to get to your 14 districts. And it turns out, as I will prove, that how you draw these lines actually makes a big difference in terms of who gets elected to Congress. And to illustrate this, and so here on the next slide here, I have how Michigan is actually divided up. And you can see that, as you kind of move north and west, the districts become bigger and bigger and bigger to reflect lower population densities. You might say, well, Mr. McCrae, you cut off the whole Upper Peninsula there. Well, no, the entire Upper Peninsula is actually also part of District 1. So you see one up there in the top. It's that top part of the mitten and then the whole UP. And so that district is obviously geographically huge, but roughly the same population there as you see little District 13 is just a little slice of the Detroit area. And so this is how we've done it since 2010. We draw these districts every census, and so we're about to draw new ones. And in most states, these lines are actually drawn by the state legislatures. So the state of Michigan, House of Representatives and Senate, votes on not only their own districts, because there are state versions of these districts as well, but also on the districts for Congress. And so these politicians who are partisan, right, they're a part of a political party, usually the Democratic or Republican Party, are going to actually choose the voters for their fellow Democrats and Republicans to run in these congressional races. And you can imagine that they want to draw those lines in such a way that it favors one party or the other, and generally speaking, because they have more votes, the districts tend to favor the party that's in power when the district lines get drawn. There's an interesting sidebar about Michigan, but I'll talk about it at the end. But for now, I'm going to prove how this happens. And we're going to do it by just simplifying it in my little thought experiment here, Blockland. So welcome to Blockland. And as you can see, Blockland is populated by 15 people, or if you prefer to think of them as blocks, by 15 blocks. And these 15 people are very predictable in how they vote. The blue people, the blue blocks, always vote for the blue party. They are blue loyalists, true blue voters. Whereas the red blocks always vote for the red party. They are red fanatics. They always vote for the red party. And it's not equal. Of the 15, 9 of them are blue 100% of the time, and 6 of them are red 100% of the time. And so you get a voting distribution that is about 60% blue and 40% red. And now let's imagine that in Blockland, Blockland gets to send 5 delegates to some legislature, or 5, representatives to some legislature that Blockland is part of. And therefore there's going to be 3 voters, or 3 people per district. And if we drew those boundaries in what I would call kind of a normal way, you could see that we would end up with there being 3 blue districts and 2 red districts. So you see here in the left, you've got 2 blue voters and a red voter, and then 2 blue voters and a red voter. So those districts are going to elect people from the blue party, because the blue party voters have majority. And then you see in the bottom right, that district is all blue. 3 blue voters in that district, so you better believe that district is going to elect a blue voter 100% of the time. Then in the top right, you have 2 districts where it's 2 red, 1 blue. So 2 red, 1 blue, 2 red, 1 blue. And so those districts, because they're majority red, are going to elect people from the red party. And so overall, your distribution is going to be 3 red delegates and 3 blue delegates and 2 red delegates. And that actually pretty well reflects the voting percentages, where you have 60% blue and 40% red. 60% of the delegates are blue, 40% of the delegates are red. Hey, that works out. What do you mean? There's, gerrymandering, no such thing. But wait, we can, just by changing the lines a little bit, these blocks will always stay exactly the same. We're just going to change the lines. I can change the proportion. See here. Let's just do straight districts. All the districts are straight up and down. So district furthest to the left, call it District 1, right? 2 blue, 1 red, so that's a blue district. District 2, 2 blue, 1 red, blue district. District 3, 2 blue, 1 red, blue district. District 4, 2 blue, 1 red, blue district. 4 blue districts. And then in the far right-hand column, 2 red, 1 blue. Okay, so there's 1 red district. So just by changing the lines a little bit, I've actually changed the distribution of power and given blue even more power. Blue now elects 80% of the delegates, even though they only have 60% of the voters. You might say, okay, Mr. McCray, I see your point. I can see that it can change, but it's not like it flips sides somehow. It's just, a magic percentage. But wait. What if I told you that I can draw these districts so the red party can actually have a majority of control, even though they only have 40% of the vote? It can happen. Behold. In the bottom of the screen, we have what's called packed. We've packed 2 of the districts with all blue voters. And so you see those 2 kind of forward L and backwards L shaped districts on the bottom are 3 blue and 3 blue. So there's obviously 2 blue voting districts. But now look at all the other districts. Top left, 2 red, 1 blue. So that's a red district. Next to it, 2 red, 1 blue. So that's a red district. And then that far district on the right, 2 red, 1 blue. That's a red district. There are 3 red districts. The red party, without getting more than 40% of the vote, has elected 60% of the delegates. They have a majority control while having a minority of the voters. So these lines matter. The interesting thing is that more and more attention has actually been played to this, and more people have started to say, hey, maybe this isn't fair. Maybe, politicians shouldn't be able to choose their voters. And actually, in our last election in 2018, we actually changed the law in Michigan so that starting after the 2020 census, these lines will no longer be drawn by state legislature in Michigan. It'll actually be drawn by a nonpartisan commission. And we'll see if their results work out any differently. What I can tell you is that when the last districts were drawn in 2010, Republicans controlled the legislature here in Michigan, and they drew districts that favored Republicans. Which is not to say that this is a partisan, that only Republicans do this. Certainly, there are strong examples of Democratic gerrymandering. You can see it in Maryland, where the Democrats controlled the legislature in 2010 and redrew the districts in Maryland, which is, a Democratic-leaning state, but not overwhelmingly Democratic, but they redrew the district to elect an overwhelmingly Democratic congressional delegation. And so both parties play this game where they can of trying to amass as much power as possible through the power of district line drawing. And so this is one way that politicians have found to kind of manipulate the democratic system simply by drawing different lines on a map. Now here comes the cool part, and which is actually your homework assignment for today. So first, just an example of a district that I think is particularly strangely drawn. You see this district in Metro Detroit includes southern Detroit, includes the Grosse Points, then it jigs totally west across kind of suburban Detroit, and then starts going northwest, somehow cuts out the entire village of Farmington, just like with scissors almost, then goes up north in a weird parallelogram thing, has a tiny little corridor, and then sucks up the city of Pontiac in it too. And so it's like, who on earth would ever draw this? This doesn't make any logical sense. There's no reason for a district to be drawn like this. You can draw perfectly normal shaped districts and still have relatively equal population within reason. The reason this was drawn is for political reasons. It was basically to pack a group of Democratic voters into space so that surrounding districts would more favor Republicans because they wouldn't have to deal with all the Democratic voters who are in that district. Your homework is actually going to be to do this because guess what? There's a game. And so what I'm going to show you here is, I can get to it, this thing called the redistricting game. And so I'll send you guys out the link to this, and your homework, and what you've got to do is you've got to take a picture of this and send it to me that you've completed it, is do mission 1 and mission 2. And mission 1 is just so that you understand what you're doing. And mission 2 is where you actually have to draw the lines and try to gerrymander the districts to favor whichever party you choose. And you can do it, there's basic and advanced. You can do it on basic. And, of course, it's a flash thing, so you got to unlock that. And here we go. All right, so mission 2, partisan gerrymander, basic. Uh-oh, now I have to pick a party. Eeny, meeny, miny, mo, catch a tiger by his toe. If he hollers, let him go. Eeny, meeny, miny, mo. I guess I'm going to be the Republican Party. And once you click through here, what they're going to give you is this map. And this map is going to, kind of like I showed you in Blockland, have voters who are blue or red. And you might say, Mr. McCrae, come on. They don't know who votes for what party. The vote is secret, right? I mean, we have secret voting. How do they know that? They can't predict that? Oh, yes, they can. They know. There's some things in politics that are very predictable, and that includes who tends to vote for what party. It tends to be that voters in urban areas tend to be more Democratic, especially because racial minorities tend to vote more for Democrats. There are more racial minorities in urban areas. Even white voters in urban areas tend to lean more towards the Democratic Party, whereas rural voters tend to be more Republican. And so depending on how you draw the lines, whether it's more urban or more rural, changes the balance here. And so, I don't know how well you can see this on the screen. Hopefully when you actually play it, it'll become clear to you. But in this example, there are four districts, and two of them are being controlled by Democrats, and two of them are being controlled by Republicans. And what it wants you to do, since I've chosen the Republican Party by just random choice here, is I'm going to try to make one of these districts flip so it favors Republican. And so there's, you can think about different ways you can do this. There are a couple of rules. For example, you have to keep the guy's house in their district because the people who are running have to live in their district. That is a rule. But what you do is you can click on a district and you can change its boundaries, but then you also have to make sure that the population's balanced. And so that becomes the other challenge here. And so my goal here would be mostly to try to look at this district number 4, since it's pretty close. Well, no, that district number 4 is pretty Democratic. I guess I'm going to look at district 2 here, which is only about 2% different, and see if I can flip this district by putting a few more Republican voters in this district, probably taking them from District 1 somehow, and then, District 1, since it loses voters, might have to go in here to District 4 and get some of those voters. And so you just kind of fiddle around with it to see if you can change the balance. And so if I draw this up this way, I can extend District 4, and now District 4 is a toss-up. It's 49% and 49%, but of course by changing, I've added more people into its population. And so I'm not going to show you me playing this the whole thing. I want you guys to kind of enjoy it for yourselves. I do know this is possible. I've done it, and your job is to try to beat this mission, and when you beat it, show me that you beat it. It'll have a little success thing that'll come up. Take the picture, send it to me as a screenshot, and that's your job for the day. So, that was our thing on gerrymandering. What I'm going to tell you is that between listening to this, taking the note, and doing this game, that's actually going to be it for both today, Tuesday, and tomorrow, Wednesday. I know that, we kind of, it was a rocky start for some of us on Monday. I thought, it was a 36-minute lecture. There were lots of notes to take, and some of you are still getting up to speed with the technology. The thing that they've told us is that it should really only be 20 to 45 minutes of work 4 days a week. So that's going to be it for today and tomorrow is this activity. We'll come back on Thursday. I'll give you something that day. And then Friday is supposed to be a catch-up day. So really, you're going to hear from me one more time this week on Thursday, and that's going to be it. Hey, it's been a lot of fun. I've enjoyed giving this. I hope you guys are enjoying it, and I will talk to you guys on Thursday.